Okay. What does it mean again? 0 to 2 pi? Yeah, we want all the x's and angles, right? We want all the angles in between 0 and 2 pi, including the 0, but not including the 2 pi. What's different about this one that we have to deal with? Well, it's quadratic, but what else is different? Different functions, right? This one's sine, that one's cosine. We need it all to be the same thing. Which could I substitute for? Could I substitute for sine squared or cosine to the first? The sine squared, right? The identity here is squared. We don't have one in terms of the other for sine and cosine. But what we have is for sine squared or cosine squared. So what will be the substitution for sine squared? Yeah, solve for the sine squared here, meaning subtract the cosine squared. It's 1 minus cosine squared. So here, this will be 1 minus cosine squared x plus cosine x equals 1. And now that looks like it'll be a quadratic. So we need to get everything on one side, 0 on the other. Subtract 1. That's good because it cancels the 1s. Now we've got negative cosine squared x plus cosine x equals 0. What will we do with it from there? Factor, right? The reason we get 0 on one side is so that we can factor the other and use zero product property. What's the common factor between these two? Cosine of x, right? So this is cosine of x. And if I factor out a cosine x from negative cosine squared, I get negative cosine x. And if I factor a cosine x from cosine x, plus 1. Okay, so we set it to 0, we factor it, and then we set them both equal to 0. So we will get solutions from this. Cosine of x equals 0. Right? Where does cosine equal 0? Pi over 2, 3 pi over 2. That's what comes out of here. X equals pi over 2, 3 pi over 2. Okay, now we can set this one equal to 0. Negative cosine x plus 1 equals 0. Right, I'm going to add cosine x to the other side, and I'll get cosine x equals 1. Where does cosine equal 1? 1, 0, right? Not 2 pi, 0. So when you get a mix there, you're going to have to substitute to get it the same. It's almost always going to be one of those three identities here, right? If it's sines and cosines, you're going to use that. If it's secants and tangents, you're going to use that. If it's cotangents and cosecants, use that. But it'll work the same way. Everyone always works the same.